All right, section 4 has quite a few things in this chapter, but we're really only going to focus on a couple. One thing that it talks about is rotating our axes so that you could have a parabola that opens at an angle, or a hyperbola that opens at an angle, or have an ellipse that's going to have a different axes. But we're not going to get into all those transformations that are happening, but it's in there and you certainly can look at it. Instead, we're going to just talk about how to use the discriminant of a general form of equation to determine what type of conic section we have. So we need to talk first, what is general form? And so general form is what we've been dealing with a lot before we've been doing completing the square to get something into standard form. So it's ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Now you may notice we've never dealt with completing the square when we had this xy term. That's that rotation of the axes, and so there's a way to get rid of that, but again, that's not what we're going to cover in this section. Instead, I want you just to see something along these lines. Now, the discriminant, you may remember from your quadratic formula days. In the quadratic formula, it was what was inside the radical, and it was b squared minus 4ac. Well, coincidentally, not coincidentally, the discriminant in a conic section is also b squared minus 4ac. But before, we used the lowercase b squared minus 4ac to determine, do we have two real solutions, one real solution, or two complex solutions. Now what this is going to help us do is by just looking at just these coefficients, the b squared minus 4ac, if we have something that is positive, so if this is greater than 0, we're going to have a hyperbola. If we have something that's equal to 0, we're going to have a parabola. And if we have something that's less than 0, then we're going to have an ellipse. Okay? Now, there are degenerate cases, and on page 673 in your book, they show you it's possible to have something of this form and have it come out to be a point, or to have no graph, or to have it come out to be parallel lines or intersecting lines. But we're not going to really worry about that so much. Let's look at an example of something that might occur. So if I have an equation that says something like 2x squared minus xy plus 3y squared minus 3x plus 4y minus 6 equals 0. I know in this case that a is equal to 2, b is equal to negative 1, and c is equal to 3, because those are the coefficients of the x squared, the xy, and the y squared terms. So if I do b squared minus 4 times 2 times 3, I'd get 1 minus 18, and that would equal negative 17. This would be a representation of an ellipse because the value of the discriminant was less than 0. That's all you're going to have to do with things like this. Now, on a test, I might give you something where I say, hey, if I didn't have this xy term, what is it based on the discriminant, and then do the transformations to get it into standard form and tell me all the pieces parts. But the thing from this lesson that I want you to understand is just how do I use the discriminant to very quickly tell what type of conic section would I have. And that's it.